Hi everyone, I'm Olivia from the Digital Farming Group at the Bavarian State Research Center for Agriculture. Here, my colleagues and I research various digital farming technologies, including field robots. I'm going to present to you our results of a survey among Bavarian farmers on their opinions of field robots.
Small-scale farmers are of particular interest to investigate in the context of field robots, as previous research has shown that robots may change the economies of scale of agricultural machinery. Whereas up until now, machines grew ever larger and thus required ever larger fields to be profitable, small robots scale differently and can therefore allow small farms or irregular fields to remain competitive. However, research into the acceptance of field robots has so far only been carried out in large-scale regions. In California, for example, expert interviews identified economic factors as both driving and hindering the uptake of robot technology. Farmer interviews in Australia showed that farmers worry about the reliability of robots, but anticipate a reduction of pesticide expenses and an increase in free time. Also based in Australia, a study identified several cognitive factors that may present an obstacle to farmers investing in field robots. When taking a look at the literature landscape on field robots, we see that very little research has been carried out on socioeconomic aspects. In fact, most of the few publications on economic topics were mainly concerned with the cost of the equipment rather than its socioeconomic impact. So the key learnings from this overview are that although the literature on field robots is growing fast, publications are very much dominated by technology and coding questions. There is a clear need for a thorough evaluation of the various impacts that field robots may have. A lot of benefits may come with broad deployment of field robots, although negative aspects should also not be ignored. A major advantage of robots may be their use as a substitute for manual labor, such as hand weeding, which is often necessary in organic production. Also, as robots tend to weigh less than conventional tractors, they can reduce the level of soil compaction and thus benefit the soil biota. Additionally, through making smaller fields economical, robots could make a contribution to increased biodiversity from a larger variety of crops within a certain area or structural elements between the fields. Due to their autonomous work, with the option of working beyond human working hour restrictions, robots can also reduce the level of stress farmers may experience during certain peaks of labor throughout the year. However, the labor market may also experience significant disruption from field robots. While they can present a solution to the ongoing shortage of low-skilled farm hands, there is also the risk that autonomous equipment may even make a certain level of training redundant because the respective tasks are carried out by the machine. Job polarization may be the result, with low-skilled labor being replaced by robots, while more high-skilled labor may be required for development and maintenance jobs. Before these questions can be answered, however, it is necessary to understand to what extent farmers are even willing to adopt robot technology. It is thus our aim to investigate what small-scale farmers think about field robots. In particular, we are interested in the size and thus function of robots that they consider relevant. Field robots may be differentiated into large and small, with large robots and small platform robots acting as implement carriers, similar to tractors. Small specialized robots, on the other hand, can only carry out a small range of tasks. With regard to these specific tasks, such as sowing, weeding, harvest, etc., we want to know how the preference of robot size changes, or whether it changes at all. Finally, given that robots are such a new type of technology, we investigate how farmers would implement them on their farm. Would farmers buy them right away, or rather use contracting services or sharing options? Would they use a rather novel option coming with digital technologies, namely robots as a service, in which the manufacturer is paid to act as a contractor? To answer these questions, we analyzed a sample of 174 survey datasets collected at 2 field events in Bavaria. Bavaria has a rather small average farm size of 35 hectares and is thus well suited to look at the opinions of small-scale farmers. In our survey, we used a 2-page questionnaire that was handed out to the participants of the field events. The data were recorded at ordinal and multinomial levels. We used bivariate chi-squared-based tests to look for significant correlations, and to this end collapsed our independent variables from multinomial answers to binary, which allowed us to draw more meaningful conclusions. Our independent variables included various farm structural characteristics, as well as the current level of use of an automatic steering system, which could be a gateway technology into even more autonomously working machines. The intent to invest in field robots was tested as both an independent and a dependent variable, with the remaining dependent variables covering a list of possible benefits and problems associated with field robots, the likelihood of ownership and perceived suitability of large versus small robots, and the mode of operation. We found that a fifth of participants were interested in investing in field robots within the next 5 years, while none had already done so at the time that the survey was carried out. The only significant influence on this decision was the cultivation system, with organic farmers being much more interested in such an investment than conventional farmers. Contrary to our expectations, however, farmers who were already using an automatic steering system did not differ significantly from non-users on this question. What advantages or disadvantages influenced the interest in robots? We found that the simplification of the daily work routine had a significant and positive impact on the intent to purchase robots, whereas worries about creating an image of alienated agriculture or ethical concerns appear to be the main barriers to a purchase of field robots. We also took a closer look at the advantages and disadvantages associated with field robots. First, considering the advantages, 3 possible benefits that farmers agreed with most strongly were reduction of soil compaction, reduced working hours, and cost savings. If we take a closer look at the farm characteristics, we can see that the cultivation system correlates with expectations of reduced working hours and the possibility of intercropping. The latter was particularly interesting to organic farmers, for whom this otherwise labor-intensive technique presents a way of pest and nutrient management, as they do not use chemical substances. Looking at farm size, we saw that the larger farms were more interested in profit increase and had a somewhat lower interest in reduced soil compaction than operators of farms below the Bavarian average. We also saw that part-time farmers consider preservation of the small-scale landscape more important than full-time farmers, which may be due to part-time farmers not having to rely on farm income for their entire livelihood and thus prioritizing differently. Looking at the disadvantages, we saw that 3 issues named most often were unresolved liability issues, market maturity and availability, and increased dependence on the manufacturer. Here, only the farm size had a significant impact, as farms larger than the Bavarian average were more concerned about questions of liability and safety issues with regard to both humans and animals than their smaller counterparts. As such, there appears to be a tendency that large-scale farmers are more concerned about the financial aspects of field robots than small-scale farmers. We asked how well farmers could imagine owning a large autonomous tractor or small robots 10 years into the future, and found that although a fifth to a quarter could see themselves owning an autonomous tractor, almost double the amount of participants could imagine owning small robots. So the first impression is thus that small robots are favored over large autonomous tractors, but a closer look at the different agronomic tasks changes the picture. We asked farmers with respect to specific tasks on the field, which robot, if any, do you prefer, and found that small robots only rank first for plant protection measures. This may be due to the market for weeding robots being the farthest developed compared to other areas, but weeding, particularly in organic farming, is very labor-intensive, so that the anticipated benefit of workload reduction may be very easy to grasp. For conventional farmers, weeding robots also represent an option to reduce pesticide use and thus cut expenses. Finally, we also looked at operation mode preferences for robots. So would farmers rather purchase a robot right away or try out this technology through sharing or contracting options? We found that the 3 traditional non-purchase options of hiring a contractor, sharing in a group, and renting from a machinery ring are the most favored options. Service by manufacturer, also a non-purchase way of using robot technology, can only be imagined by just over a third of participants. But if we recall the 3 possible disadvantages that farmers were most concerned about, unresolved liability issues, market maturity and availability of robots, and increased dependence on manufacturers, the hesitance of farmers to directly purchase robots can easily be explained. Through non-purchase options, they can benefit from the new technology and gather experience without having to carry the full financial risk of potential legal issues or obsolescence as robot development progresses. The low level of preference for service by manufacturer may be due to this concept being quite new, but also due to farmers not wanting to become too dependent on manufacturers. So what are the key messages from this first investigation of small farmers' views on field robots? We learned that organic farmers are more interested in field robots than conventional farmers, as they expect benefits from workload reduction. Overall, the main obstacles to robot adoption are ethical concerns and worries about creating an alienated image of agriculture. This means that the benefits of robots need to be communicated clearly to both farmers and the public, and that the public needs to be involved in the technological transition in agriculture right from the start to ensure its support. Regarding robot size, we find that small robots tend to be clearly preferred over autonomous tractors, but at the moment they appear to be only considered suitable for plant protection measures. Finally, traditional non-purchase options, which allow farmers to reduce their financial risk, are the favored way of entering the field robot market.
Thank you for your attention. I hope these findings were interesting for you. I look forward to your questions and comments at our discussion on November 10th.